Yeah, so I've started recording this session. So the previous session we covered like the syntax of propositional logic. So yeah, just like a refresher, the syntax is just like a grammar analog of propositional logic. We all we are doing is that we are defining the vocabulary of propositional logic, and we are defining rules for constructing well-formed formulas. A well-formed formula is simply like um, a proposition that is constructed according to the rules or the syntax of propositional logic. So, for example, these like P and, or P not Q, or P. These are all not well-formed formulas. Similar to how in English language blue sky is not a correct statement, but the sky is blue is a correct statement. Um, Apart from that, there are like four rules of propositional logic for forming well-formed formulas. We use alpha, which is a meta-linguistic variable, to denote like for it to be like a placeholder for a proposition. So this is any formula basically. So any formula is well formed if it is like represented by a single letter and it is actually a proposition. Rule 2 is any proposition is a well-formed formula if any formula is a well-formed formula, then its negation is also a well-formed formula, and so on and so forth. So we're not going to read everything, but basically, yeah, there are like different rules for constructing well-formed formulas, um, and we try to like prove that something is a well-formed formula by just applying the rules, right? So we applied so if you want to check if this is a well-formed formula, you identify the atomic propositions, the atomic well-formed formulas, and then you apply the rules. And if you are able to apply the rules throughout, then it is a well-formed formula. So for example, alpha is a well-formed formula, not beta is a well-formed formula, alpha and beta is a well-formed formula. So we have proved that this entire thing is a well-formed formula. So yeah, we have also like sort of codified how to check for well-formed formulas, identify the atomic formula, identify compound WFFs, and then check rules. Basically, that's it. And then at the end, when you have the biggest compound propositions and when you find the biggest well-formed formulas, there is going to be like a connector or an operator between them, and that is going to be the main operator. Okay. And today what we'll do is we'll try to we have already done truth tables, but what we'll do is be more thorough about how to build like a truth table. So how to build truth tables. Okay, so let's just take the first step. So the first step will be let me just write it like this. Wait, let me check. No, I used white last time. Yeah. Okay. The first step is count the number of unique there is some music in my background. I'm not sure if it's going to be captured by the mic, but okay, whatever. So yeah, so the first step is you count the number of unique prop variables. Okay. So let's sort of see what that looks like. So for example, we take a proposition P and Q and R. So how many unique propositional variables do you see here?
I see 3.
Okay, so that's one, that one, and that one, right?
Right.
So if you want to look at something like J or V, how many do you see here?
Here I just see 2.
2 of them. Okay. So you've counted the number of unique propositional variables. And the second step will be determine the number of rows. Number of rows. Okay, and for this we will apply the formula that we learned earlier. So it's just 2 raised to n, and n is the n is the number of unique. So this entire thing, that's n. Okay. So let's say in this case, okay, P, Q and R, what would n be? N is 3, right? And if we take 2 power 3, we get 8. So this is the number of rows that we have. Okay. Next step, we draw the first few columns of the truth table. And the first columns of the truth table will be declaring all the unique propositional variables, and listing out the possible combinations. Basically filling out all the rows. Okay, so declare PVs. I'll just abbreviate it as PVs, and fill rows. Okay, so we know there are going to be like 8 rows, right, for this particular proposition. So what we'll do is first we'll declare P. Okay, we'll just declare, so this is the first column P, this is the second column Q, this is the third column R. Now for the first column, what we are going to do for filling the rows is we take that number, right, 2 power 3, that is 8. So I'll write it here just in case. So this is 8. What we're going to do is just divide it by half. Okay, and that answer is obviously 4. So what we'll do is the first 4 rows will be true. And then the rest of them will be false. Okay, we do that for the first one. For the second one, we divide 4 by 2 again, and that yields us 2. So what we're going to get is true, true, false, false, and then you just repeat the pattern. So that's true, true, and false, false. And then for the third one, you just divide 2 by 2, and that will give you 1. So you put 1t and followed by a f, and then you just repeat the pattern. Okay, you got that much? Any problem?
Okay, so let me just just explain back what you said.
Yeah.
So first row, it's 2 divided by 2, and so it's just we just get 4. So it's just 4 t's and then 4 falses, and then for the row number Q, we did
Wait,
2
1 sec. So
divided.
you said, so the first one is the number of rows divided by 2. So for example, here we have 8, right? So 8 divided by 2, you get 4, not 2. So you get 4. So the first 4 are trues and then the rest are false. Okay, yeah, go ahead.
And then what did you do for the second row?
For the second row, I just divided the 4 by 2 again.
Oh, okay. So you take the 4, then you divide it by 2.
Yeah, so
Yeah,
for
and then-
example,
and
I'll
then-
just write it here for reference. So this will be 8 by 2 plus 8 by 2. Okay, so 8 by 2 trues, 8 by 2 false. So that's 4 trues and 4 falses.
Okay.
And this will be 4 by 2 trues and 4 by 2 falses, this one. And then you just divide that further. So 2 by 2 trues and 2 by 2 falses.
Mm-hmm.
So you start with this 8 by 2. So you get 4 trues and 4 falses. That makes us 8. That makes 8 columns. Sorry, 8 rows. And then for the next one, you divide it by 2. So you get 4 by 2 and 4 by 2. So you get 2 trues, 2 falses, 2 trues, 2 falses. And then for the third one, you just do true, false, true, false, true, false.
And then the 2 by 2 means that you're doing true then false, true then false.
Yeah, exactly. So let's do that for the 2 by 2, right? So let's say P, Q. Okay. So how many rows will there be?
So this one is, we've got 2 variables, so it's 2 to the power of 2, which is 4, yeah?
Yeah, and this will be 4 by 2 trues and 4 by 2 falses. So how much would that be?
So we got a true there,
Okay.
and a false,
No.
right? I'm not really following what you mean by like the by exactly.
Okay, yeah. So 1 second. Yeah, okay. Yeah. So you have 4, right? 4 is the number of rows. So you have 1, 2, 3, 4. You need to fill
Yeah.
4 rows.
Yeah.
So for the first one, what you're going to do is just divide the number of rows by 2.
Yeah.
And you're going to pair the truth values in that combination. So you're going to divide 4 by 2. So you get 2, right? So in
Yeah.
the first column, you're going to have a pattern of 2 trues and 2 falses.
Okay, so that's what the 2 means. So just 2 trues, then 2 falses.
Yes. And if you notice all the previous truth tables you've made, that's the pattern we have followed.
Yeah, yeah.
And for this one, what you're going to do is just divide this. Just divide the 2 by 2. So you get a pattern of 1 true and 1 false. So that's 1 true, 1 false. 1 true, 1 false.
Right, and then or the column R which we saw. So this is a pattern 1 1, right? For the Q column.
1 sec.
So you see-
This is for the 2 by 2 grid. So this for the 3
Yeah.
by 3 for the 3 not the 3 by 3 but like the 3 variable grid, you have 8 rows, right? 1 2 3 4 5 6 7 and 8. So for the first variable, what you're going to do is divide that by 2. So how much do you get?
We get 4.
Yeah, so you pair 4 trues and 4 falses.
Yeah.
And for the second column, you're just gonna
Yeah.
half it. So that's like 2 trues, 2 falses, and that pattern repeats. 2 trues, 2 falses, 2 trues, 2 falses.
Mm-hmm.
And for the the next one, you're just gonna half it further, so you get an alternating true, false, true, false, true, false pattern.
So shouldn't it be like the above the R? Shouldn't it be like a 1-1 pattern?
Yeah, it's so 2 divided by 2 is 1, right? So
Yeah.
it's the same thing.
Yeah.
Yeah. I mean, I wrote 2 by 2 thinking that it would be more intuitive, but it's fine. We can just write this as just like literally like 4 truths, 4 falses, 2 truths, 2 falses, 1 true, 1 false. Okay?
Yeah.
Yeah. And yeah, so we have built the propositional, we have declared the propositional variables for 3 variables. So let's, so what do you think we'll do for the 4 variables? Let's try for 4 variables. Now, at some point it's just going to be more like, because this increases, like, yeah.
Yeah, so it's 2 to the power of 4 this time.
Yeah.
So 16.
Yeah. So let's say P, Q, R, and S, right? And we're gonna have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wait, what? 10, 11, 12, 13, 14, 15, and 16. Okay. So we have 16 rows. How will you fill the first one?
So for the first one, we take the 16 then and we divide it by 2, right?
Yep.
So we get 8.
Yeah.
So then that's, we do 8 truths, then 8 falses.
Okay.
Am I following?
Yes.
This is a very long process.
Yeah, once it gets like, we won't be doing 5 and all of that. Like, it gets really cumbersome. But yeah, like, I wanted to do this just to get you familiar with, you know, how to expand a truth table.
Okay, so then we have the 8, and then we divide that by 2 again. So now we do, we got 4 truths, then 4 falses, 4 truths, right?
Yep.
4 falses until we get up to 16. So that pattern 4 times.
Yeah. That's right.
And then, so now we do the same thing then, but yeah, once you finish this column, now
And
we
then
get
I'll
the
just fill it in reverse.
4 divided by 2, so this time it's... Wait. So it's 4 divided by 2, right?
Oh, sorry. Yeah. Yeah, I thought, yeah, it's 4 variables, right? Yeah. So that's 2 falses, 2 truths, 2 falses. And then this will just be alternating pattern. The last one is always going to be like alternating pattern.
Okay, I think I'm understanding it.
Yeah. Okay, yeah. So this is how you're gonna be like expanding a truth table. Like, you can just go infinitely. But I doubt you are ever going to make a truth table bigger than like 3 variables or something like that. We actually have better ways of proving, you know, I don't know, like just like proofs, like arguments or whatever, proving validity, all of that. So you're probably never going to use truth tables, but even if you want to draw like a truth table, even if you want to use a truth table, that's one way. So showing all of this is like one way of showing validity or something like that. A truth table is one of the ways, not the only way. It's one of the ways. But it's also like the easiest way to understand. So that's why that's why it's generally taught first. So I'll just, so now what we'll do is, now we want to build the truth table for this, right? So how will we do that?
So
So we have this, we have declared the propositional variables.
Yeah. So we can do, is it two, do we put a column for two conjunction? Well, I don't know.
Yeah, so what you can do is you can do one column for P and Q. Okay. And then you can do a P and Q and R. Okay, so this will be one column, and this entire thing will be one column. Because see, this is one formula. Okay, this is a formula.
Okay, so we need to add the brackets to make it a well-formed formula, right?
Yeah.
Yeah.
I mean, even without the brackets, it's a well-formed formula because this is like a conjunction. But yeah, if you have some more compound proposition, maybe you have like a mixture of biconditional, conditional, conjunction, disjunction. If you have a mixture of that, then it's you need to be careful. So here, because it's like just three propositions connected with conjunctions, you can either add a bracket like this, or you can add a bracket like this, and it doesn't matter. Both of them are the same thing. And that's what we wanted to prove, right?
Yeah.
Yeah. So what we'll do is, first we'll make a table for this. So what would this be?
So the first one, we have it all in brackets, and then the R on the right hand side, right?
Yeah, for now we're just doing a P and Q, conjunction of P and Q.
Okay, so then we just take what's in the first two columns, so T and T, so it's a T, right? And then so conjunction that is true when they're both only true, so that's a false then, right? Right? Because if conjunction is only true if they're both true.
Yeah, that's right.
So then the next one is false.
The next one is false. Yeah, the following one is also false. This is also false. What about this one? This is also
false. And then this is also false. Also false.
Okay. Now you have the table. You have this table, right? And what you want to do is P and Q and R. So what you'll do is just compare this table and apply the rules of conjunction with this column.
So true, and then false, 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 all falses.
Right. Okay, so...
Okay. Yeah, I think I'm tracking.
Yeah. So was true, this was true, but these two are false. All of them are false, right? So this one is entirely false. Just except the first one.
Yeah.
Now, what I asked you to prove was the opposite of it. So now I want you to prove... I guess let's try that question now.
So you want me to share my screen or?
One sec. So before we go there, let's just go to like the next the step. So basically, let's go step by step, right? So we've built that. And now what we're going to do is basically wait one sec. So we have identified all the individual variables, and we assign like values to each of the, we assign all the possible values, all the rows from to each of the this thing. And then what we do is like we work inside out. We go from smaller to the bigger propositional variables. Oh man, where is that? Okay. Step 3. Where is it? Step 3. Okay. Yeah. Okay. So that's step 4. And step 4 is okay, so you've counted the number of unique propositions, you've determined the number of rows needed, you declared all the variables, and you filled the rows. So now what you do is you start determining the columns for the the smallest compound proposition all the way to the biggest proposition. Okay, so for example, over here, this was the smallest that we could get. So if this is the proposition that we are looking at, at least one conjunction is gonna be like the minimum needed. Like you need at least one conjunction, and then you can add another proposition to it to make the entire thing, right? So you work inside out. Move from smaller WFFs to larger and draw columns. Okay. Did you get the last one?
I think I need to see it in practice a little bit more.
Yeah, sure. Okay. Yeah. That's all right. Okay.
But I think I roughly understand what you're saying. But
yeah.
So you just you start with the atomic propositions.
Yeah. So when you're declaring the variables, right, you're starting essentially with the atomic proposition, and then you go to the bigger and bigger columns, bigger and bigger well-formed formulas, and you draw out their columns, and then you apply the rules basically. So it's just like applying the rule of well-formed formulas. You're just making the well-formed formula bigger and bigger until you finish the entire proposition, and that's how you get the final the final one. So now do you want to try applying this to the question I sent you the other day?
Well, this is half of the question, right? Already.
Yeah, we have already done half of it. So let's check that out.
So I guess just for ease, you can just, would you rather you write or would you rather I share my screen?
We could do either.
I guess because we have the first half here, save me time having to write it all up.
Yeah, no problem. Yeah.
You can just write it underneath, or
yeah, I'll just expand this table like horizontally. I'll get rid of this, okay? Like I think you get what I mean. Like I don't need to show you like.
I think I got it. Yeah.
Yeah, you got it right. Oh, okay. I'll just expand this line. And then draw this line. And then I'll draw another line over here. Okay. So we wanted to check. So this is one of the forms, right? The
Yeah.
other form is gonna be like this. So we have already figured out the table. We have already figured out the column for this because we literally declared this as a variable, right? And the next one we want to figure out is this.
Yeah.
Okay, so that's Q and R. Right? Okay, so let's draw the table for that.
So then it's true, false, false, true, false, then true. Sorry, the one I said was false was true was actually false. Yeah.
Oh,
So-
1 second.
So I did false and then false. Also false, and then false, false, false.
Right? I'm not checking.
But yeah, the only one where they're both true is on the first row, as far as I can see.
No, there is another. There's
Oh no, they're also the same on row 3.
row
Oh
three.
no, we're looking at Q and R. I'm reading the wrong column actually. So no, row 5 they're also the same. Yeah.
The row 5 is also a true. Yeah.
Okay, so we got Q and Q and R. We got a conjunction there.
Yep. And now we are going to expand the conjunction to P and Q and R.
And now we put the brackets.
Okay, so what would this be?
So now we're reading all the way from the first column all the way on the left where the P is and the Q and the R. So yeah, this is true.
Okay.
Then false, 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 false.
All false?
Yeah.
Okay. Now compare this, right, to this.
Yeah, both the same.
They're both the same. And when two propositions have the same column configuration, they're called logically equivalent.
Yeah, with the three horizontal bars right
Yep.
between them.
Exactly. So P and Q.
Is that the same as a biconditional or not? Because they have the same
Yeah,
truth value.
it is actually, well, it is the same as biconditional. But technically speaking, it's it's more of like a it's basically the same as a biconditional for all intents and purposes. But like there's like a small detail, like it's actually not exactly the same as a biconditional. We'll probably cover that later. But yeah, for all intents and purposes, it functions the same way as a biconditional. P and Q and R. Okay. I'll sort of as an Easter egg, I'll tell you that this is a rule of equivalence called association. Okay, so this is called association. It's a rule of inference called rule of equivalence called association. We will cover rules of replacement in detail later, but I just wanted to give you an interesting sneak peek into what's coming later.
Cool.
So
Thanks.
we're gonna have a bunch of these kinds of replacements. So anywhere you see this proposition, you can just replace it with this proposition, and you can for instance, there could be some proofs where you have this form but you actually need this form. So you replace this form with this form and you continue your proof. So they're
Cool.
like sort of like, they're called rules of replacement. So we'll cover that later. But yeah, I just wanted to sort of give you like a sneak peek.
Right, got it.
Yeah. So I think you understand this one, right? So you move from the smaller well-formed formulas to the larger well-formed formulas and you draw the columns.
So, in which part of the process did we apply for exactly?
Oh, in this one. So the last column we applied 4. So we went from, both the last and the second last columns. So we started with the smallest, which is declaring the variable. So in this case, P and, let me actually give you like a more complicated example. Just to like make it, just to like solidify it.
Okay.
Let's say, let's do it with a 2 variable thing. Should I do a 2 variable thing or should I do a, I'll just do a 2 variable thing. Okay. So let's see P, let's say Q. How do we fill? We fill it with true, true, false, false, true, false, true, false. Okay. I think this you can figure out.
Yeah, just 2 to the power of n. Yeah, 4, and then the first column 4 divided by 2, then 2 divided by 2. Yeah.
Yeah. Oh, sorry, one sec. So you have P or not Q. Then you have an AND. Okay, so this is the proposition, okay? P and not Q and Q implies P. Okay, so this is the proposition we want to draw a truth table for. So what you do is, again, step number 1, which is count the number of unique propositional variables. We have counted them to be 2, right? And we have declared the variables. So that's step 2. We have already declared the variables and we have filled the, So we are counting as the first step, P and Q. We have counted that. Second step is you have determined the number of rows you need, which is 4. We have done that. We have done step 3, which is to fill all the rows for corresponding to the propositional variables. So we have done that. Now what we do is we go from the smaller well-formed formulas to the bigger well-formed formulas. Okay. So this entire big thing is one well-formed formula, right?
Yeah.
And then we break it apart into smaller well-formed formulas.
Mm-hmm.
And you could also like break the, brackets further. Like let's say there is some proposition in there which contains some more brackets. So you break those brackets too until you get like something that's a compound proposition but is also not like an atomic proposition. So in this case we don't need to do that. It's just like math. So when you're solving like math equations, you solve the brackets first. So you make all the brackets, you solve all the brackets inside and then you solve the big bracket. So all the inner brackets are filled progressively from inside to outside, and then you solve the bigger brackets. So same thing would apply here. You will split it apart by the brackets. So here we have 2 propositions. We have P or not Q, and then you also have Q implies P, and then you have the big proposition, P or not Q and Q implies a P. Okay, so this is the big proposition, which is further divided like this. So here you've done this. Let's also declare the variable column for q. Okay, so because not q is another variable there, right? So that will just be like the negation of this, so that will be false true false true. Okay, and then you solve this, so the disjunction of p and not q, so that's this and this, that's false. This and this is true. This and this, that's false. Yeah.
Wait, so that's the disjunction, right?
Yeah.
So we got P is true.
Oh
so
yeah,
in
sorry. Yeah. Sorry. Yeah. So this is true. Okay. This is true. This is true. This is false, and this is true. Okay.
Yeah.
Yeah. And this one, that's Q implies P, right? So that's true. That's true. That's false. And that's true.
Wait, they're both false, right? Q goes to P.
They're
Two
both
falses
false.
I can't remember in a conditional true. Two falses are a true, right?
Yes. The only case where a conditional is false is when the antecedent is true and the consequent is false.
Okay.
Sorry, the only case when the conditional is false is when the antecedent is true and the the consequent is false.
Mm-hmm.
So here the antecedent is true and the conditional the consequent is false, so the conditional is false, right?
Yeah.
Here the antecedent is false and the consequent is true. That's true. Both of them are true. That's also true, and this is also true. Okay, so that's yeah. Okay, and now we get the conjunction of this and this, which is basically going to be what?
So conjunction, that's a true. Because they're both true, then true, false, true.
Yep.
So we basically built it up right from the atomic, propositions upwards, right? And now we have the whole compound proposition there solved.
Yeah. So we have true, false. Wait, I'm moving my cursor in the wrong. So we have we have true, false, true over here, right? And then we have true, false, true over here. And then we have just put a conjunction between them, so that's true, false, false, true. Okay. Yeah, that's basically it. So that's that's how you draw a truth table for any proposition. So I'll just write this is like math. Board mass. Okay. Yeah, so that's basically it. So that's how you draw a truth table. Okay. Do you want to do more examples, or what do you want to do?
I think I've got it. Maybe I'll make some errors along the way, but it's just getting the practice in. But I think I understand it.
Yeah.
So I think we can, if we have time, we can try. We were planning on trying some. Or is it semantic, or is there anything else to cover with drawing truth tables?
Well,
hello?
I think.
Yeah.
Hello. Yeah. Can you hear me?
Yes, I can.
Yeah, I think that should be like good enough. I guess you'll just need like some practice, right? You'll need to you'll have to check how to draw each of these. So I guess that I'll probably send you like a bunch of exercises and you can try those.
I'll link them for people to try as well.
Yeah. Yeah. I am not sure if we should just go with semantics at this point. Yeah, it might take longer. That's well.
So up to you. If you want, we can wrap it up there and do semantics next time.
Yeah. Yeah. Let's do one example and then we'll call it a day. So that at least we'll spend some more time with this, just to not leave any loose ends, right? And then next time we'll do rest of the semantics. Okay. So I'm pulling like an example from the book. So so this will be let's see. So B double implies C. That's in a bracket. That implies A implies X. So this is the proposition you want to draw a truth table for. So let's go. This is going to be a big one.
Yeah. So we identified the number of propositional variables. There's 4 there. So then it's 16 rows we're going to need.
Yeah. Okay. So that's 2 raised to 4. That's 16. So we're going to need 16 columns, right?
Yeah. And then we'll have 8. Well, we first labeled the columns, I guess. So we have.
Let me just write this quickly. 10, 11, 12, 13, 14, 15, 16. Okay, we have 16 rows. Okay, what do we do first?
So first we write out the letters on the columns. So we can we do them in alphabetical order or just write B, C, A?
Yeah, you can do alphabetical order, it doesn't matter.
I think yeah, we can write it out as it is, right? Just because it might help.
Yeah, sure.
Not having to move our eyes too much then.
Yeah, sure.
So then B, C, A, X. So then first column we just have 8 truths and then 8 falses.
Okay.
And then we have the same thing but with 4 instead.
I'm just gonna take a shortcut by copy pasting this.
I guess it'll be quick to do it in that Microsoft Excel. Something.
Yeah, absolutely. It'll be way quicker to do it in Microsoft Excel.
Have you seen people do it in Microsoft Excel before?
Yeah, I think that's what I used to do. Yeah, at some point I used Microsoft Excel.
Okay. So then next column we have 2. It's in 2. 2 by 2.
Oh,
so
sorry.
then,
Yeah, 2 true, false. I'm just gonna copy that.
copy it once and copy it again and paste it, I guess.
Yeah, it's a bit cumbersome. That's why everybody hates truth tables.
Then the last one is going to be alternating.
Yeah.
the TF.
I think that's gonna be faster to, sorry. Okay, we did the mammoth task.
So now we can draw out the different units of the columns for the first brackets set of brackets, and the biconditional BC, and then draw another column for the no, sorry, the BC is conditional.
This is a biconditional.
Biconditional. Okay, I forgot the word for it, but yeah, material biconditional, and then AX is a.
So we have identified the individual units, right? So this is one unit, and this is one unit. So this is one formula, this is one formula.
Mm-hmm.
This is the main operator. So we'll do like the biconditional table, right?
So biconditional is the same when they both have the same value. So we have T, F, T.
Wait, why do we have F? It's true.
Oh no, sorry. I was reading the wrong columns actually. So
I gotta be careful with that.
F, false, and then false. Keep on going, and until you get up to row 13. And then they're all trues.
Yeah. Okay.
Then now this time we have a conditional, and it's a application A between to X, and so we have true, false, true, false, true, false, true, false, true, false, true.
Okay. And then we have the big one.
So now between them we have another conditional. Yeah?
Yep.
Material conditional, so true, false, true, false.
Wait, where would that be?
Where are we now? We're on row 11. Yes, that's a true, false, true.
Yep. So that's the table.
Yeah, it's easy to make a mistake.
It is easy to make a mistake. Yeah. So let's look at the solution to the problem, and we'll see if we got it correct. So that's 2.4. Where's that? 10. Wait. What?
You made a mistake.
No. I think we did one which is
without a solution.
Like the solution is without a solution.
I guess if someone spots a mistake, they can send us a message.
Yeah, I don't think there'll be. don't think there will be a mistake. Wait, am I looking at the correct? Let me check. So that's BCAX, right? Where did I pick it from? I have no idea where I picked the question from.
Well, I guess it's not too important if you cannot find the solution.
Yeah, it's not. I mean, yeah, the whole. Yeah. Yeah, screw it. Yeah, anyway. Yeah, I don't think there's a problem with this.
But I'm guessing truth tables, we use it, for example, if someone has an argument and we have a specific, if we think, for example, one variable is false, one is true, or something like this, and we use it to evaluate the overall proposition.
That's right. Yeah, that's how we do it.
So, interesting.
Yeah.
So we'll see that later, I'm guessing, for sure.
Yeah, we will. Yeah.
Great then. I guess next week it'll be semantic.
Yeah, we'll finish rest. I mean, we have already started going into the semantics. But yeah, we'll get into. We'll go sort of deeper.
Cool. Right. Thanks for that.
Yeah. No problem.
Take care.
Yeah.